This video is for pre-calculus, and it's going to cover Chapter 3 standardized test preparation questions. I gave this as a preview to Chapter 3 that students should be working on the entire chapter. So I'm just going to go through basically the answers on this packet. So the first question you can see up at the very top here, I've got 8 to the x over 2 equals 4 to the x plus 1. When solving for a variable in an exponent, if you have an equation like this where you've got one number raised to an exponent, another number raised to an exponent, the variables are in the exponent, what you're trying to do is have the same base on either side of the equal sign so that you can set the exponents equal to each other. So in this case, 8, well, that's the same as 2 to the third. And 4 is the same as 2 squared. So that gets me to 2 to the 3 times x over 2 equals 2 to the 2 times x plus 1. Now the bases are the same, so I know 3x over 2 equals 2x plus 2. And then multiply by 2, I have 3x equals 4x plus 4. Solve for x, and x equals negative 4. So that would have been answer D for the first one. On the second one, you've got domain. Give the domain in range of f of x equals negative natural log x minus 1. Well, on that one, the domain is what numbers you can plug in for x, obviously, as always. So if I have x minus 1 inside the natural log, remember the restriction is it's got to be a positive number. So that tells me x minus 1 needs to be greater than 0, which means x needs to be greater than 1. So that's my domain. Well, it looks like that's my only option. The range is all reals because we know what the natural log function looks like, or the opposite of the natural log. You're still covering all y values. The third one, write 4 times the common log of x minus 4 times the common log. It looks like an exponent, but that can't be. It's just the common log of z plus the common log of x. So what I'd do here is I'd look at the 4, bringing it in as an exponent here and here, and then subtraction means divide, addition means multiply. So I've got log x to the 4th divided by z to the 4th, and then this one's going to be times another x. Well, x to the 4th times x is x to the 5th, which means A must be our answer right there. Number 4, Jamal invests $1.5 million at an interest rate of 8%, compounding quarterly. How long will it take until the account exceeds $5 million? So we're looking for when does the account get up to that $5 million mark. So we're looking at $5 million needs to equal my initial investment times 1 plus my interest rate, 0.08, divided by how many times a year, which was 4 since it's quarterly, raised to the, well, I'm looking for how long will it be until the account exceeds 5 million. So I would raise that to the 4t and then solve for t. So to do that, I would do 5 divided by 1.5 would equal, what's in those parentheses? That equals 0.08 divided by 4 would be 0.02 raised to the 4t. And then kind of ran out of room there, but from there, this is your base. This is what equals exponent. So remember, when you're looking for an exponent, or the variables in the exponent, you use a logarithm. So I would take the log base 1.02 of 5 divided by 1.5. That would equal 4t. And then just divide that answer by 4 to get your t. Type that in and got 15.2. Number 5, describe how to obtain the graph natural log negative x plus 2 minus 3 from the natural log. It's easier for me when I factor out a negative there. Natural log of negative x minus 2 minus 3. That tells me that negative sign right there is going to reflect in the y-axis. This minus 2 here is going to shift it right 2 units, and then this minus 3 here is going to bring it down 3 units. So D would be your answer. And then just checking my time so far. We're almost at 6 minutes. For this next one, the complex conjugate of 2 minus 3i. Well, you just need to know what the complex conjugate means. So your answer is going to be B, 2 plus 3i, just the opposite sign in between. Write a logarithmic expression that's equivalent to the exponential expression shown. So that's, again, do you know what's being asked here? Kind of hard to read on the screen right now, but it says 3 to the a plus 1 equals 4b. So the base here is the same as the base in my logarithm. I'm trying to find the exponent, so I have to do that of 4b equals a plus 1. And that is the same thing that D says. So for number 8, so what do the points form? Okay, so I'd look at those points. Usually I'll just make a quick sketch. We've got negative 2, 1 somewhere right there, 3 11s up here, 7 9s over here. I'd expect if there's a right angle to check right there. So I do my slope of this line right here first, which would be 11 minus 1 over negative 2. 11 minus 1 over 3 plus 2, which would give me 2. And then this right here would be 11 minus 9 over 3 minus 7, which would be negative 1/2. So there's a right angle formed. You know it's a triangle. Must be a right triangle. And the last one on that page was, which of the following parametric equations are equivalent to y equals cosine x minus 7? Well, if you just look at these equations, there's not much to them. X equals t, so I can replace the t in this one with x. I get y equals cosine x minus 7. Well, there was A right there, right away. Otherwise, why is this one not? This is x equals cosine y minus 7. This one over here would be x equals, take that back, solve this side and we'd get t equals y plus 7, so x would equal cosine y plus 7, and so on and so forth. You could do D yourself, but we already had the answer. Alright, so here's number 10. We've got the graph of y equals x minus h, that quantity squared minus 9 is, what is it? Well, it's only the x is being squared, so it's some sort of parabola, and a parabola doesn't have a center. It has a vertex, and that vertex is at minus h plus k. So h would be the x value, and negative 9 would be the k value. So D. Number 11 here, which of the following statements is true? Looks like if you glance through the answers here, you're looking at continuity. Is it continuous, and so on. So just kind of glancing through here. When it's less than 0, it's your cosine function. So if you think of a graph, your cosine function is going to look like this. Less than 0. 1 minus x if you're between 0 and 1. So that's got 1 for an intercept, and it's a negative slope, so it's going to be going down the slope of 1. And then at once x equals 1, y equals x. So if x equals 1, y equals 1, or I'm sorry, y equals x. So you go through the point 1, 1, like so. There's discontinuity at x equals 1. Hopefully you got that. Maybe rewind it. Try to slow down my voice there if you need to on that one. Find the inverse function here. The equation's g of x equals the natural log x cubed. How do you find inverse function? You switch the x and the y around. So you'd have x equals the natural log of y cubed. So what is that saying? Well, that's saying if you do the swoosh thing here, e to the x needs to equal y cubed. And so y would need to equal the cube root of e to the x, which would be e to the x over 3, since cube root means 1/3, raising to the 1/3 power. And that looks like we've got A for an answer. Let's see, that's number 12. Number 13, determine an algebraic formula for the exponential function passing through the points given as shown. So this tells you right here your initial value is b, and goes through the point 3c. So we need to use c equals b times a to the third to the 3 times k, excuse me. So then we're looking to find, I'm sorry, let me back up. I mixed a couple things together there. Let me find this equation for you so you know what I'm thinking in my head here. So the first time there I was kind of mixing a couple things up. After looking at the way these answers look, they use that E. So that's the form that we're using. If you look back in your notes, we used that here. Oh, that's awesome. Use that right here. So A is the initial value, and then K is some constant that works with it. Well, we're going to find that constant since we know we're supposed to use B for our initial value. So then 3, C would equal the initial value B times E to the K times X, and X is 3. So now we solve for K, so we'd have C over B equals E to the 3K, and so we know the natural log of C over B is going to equal 3K. So then we divide by 3. So it's like putting a 1/3 out here. Get rid of that 3, and that's solving for K. So now we plug that back in for the K right here, and I'm sorry, not right there, but that's the K value that we'd use, and we'd still have 3 as X. So if we clean that up, we still would have Y equals, we said B was the initial, E to the K times X. Well, K is 1/3 natural log C over B times X. And that's letter B here. That was a good one. That was probably one of the harder ones algebraically to solve. Next, we've got determine the values of C for which that quadratic can have exactly 2 real roots. Well, it's going to have 2 real roots if the discriminant is positive. So your b squared minus 4ac, I'm sorry, b is 2c. B squared, there we go. is 4ac if that's greater than 0. Well, this would be the same as 4c squared plus 16. Well, there's no number I could plug in for c that wouldn't give me a positive value. So all real numbers work. Let y equals mx plus b, where m and b are real numbers, m greater than 0. Then the average rate of change between any 2 points on the graph will, well, average rate of change is the slope, so it's m, and it is increasing. All right, on to the back side. We've got find the horizontal asymptotes. So for 16, when the equation is in that form, you'd have, your horizontal asymptotes are going to be when you take your 12 divided by 3, because this can end up getting down to basically nothing, which is going to be 4. So y equals 4. So horizontal asymptote. And for 17, Springfield is 3,500 in 1940. Assuming the population is increasing at a rate of 3.2%, what will the population be in 2005? So for that one, we're looking at what's our initial value, 3,500 times 1 plus 0.032, and then how long is it from 1940 to 2005? So 65 years. Plug that into your calculator, and you should get 27,118. Solve this equation for number 18. So that'll be natural log both sides, so you get 2x equals natural log of 3, so divide that by 2. That's approximately 0.55. So for this one, solve the equation. All the bases are natural log, so you can combine the first two. 3x minus 2 times x minus 1 equals the natural log of x squared if you bring that exponent in. So, got natural log on both sides, so 3x minus 2 times x minus 1 is going to equal x squared. Simplify that down, bring that x squared over. You got 2x squared minus 5x plus 2 will equal 0. And then, scroll this down a little bit. And then, suppose we'll throw it in. Oh, we could factor that. Might as well do this. Square root of 25 minus 4 times a times c all over 2 times a is 4. So I get 5 plus or minus 3 over 4. Can't be a negative, so the answer is 2. The answer is 2. $250. Number 20 here is invested in an account, compounded annually. 2 years later, there's 273.53. What was the interest rate? Okay, so it's going to be 1 plus that interest rate. Since it's annually, you don't have to divide by n there. Did it for 2 years. So take this divided by 250, gets rid of that. Square root gets rid of that. Subtract 1. You get 0.046 or 4.6%. Done. All right. Tried to go fast so it wouldn't take you too long. That was your review. Hope you enjoy it. See you in class.